Let's take these examples. An object of mass 15 kg is at the point of sliding down a plane, inclined at 36 degrees to the horizontal. Find the least force parallel to the plane required to make the object begin to move up the plane. We want to find the force required to make this object to begin to move up. That's P, the force that will make it to move up. For it to move up, this force required for it to move up, P, which we are looking for, must overcome the limiting frictional force, F, and this horizontal component of the force. So the force we are looking for is P. Remember, if it has to move up, this P will pull it. It will pull it. So it will be greater. It will be the resultant force of these two forces. So let's write out all the parameters that we are given. Given the mass as 15 kg, the angle theta is given as 36 degrees. G is given as 10 meters per second square. So the force that we are looking for, P, will be equal to F plus W sine theta. So that force that must cause it to move up the plane must be equal to the sum of these two other forces. Remember that F is equal to mu R. So we are going to write mu R plus, remember that W is equal to mg sine theta. So if we break it down further, P will be mu and R is equal to mg cos theta plus mg sine theta. How do we get mu? M is given, G is given, theta is given, M is given, G is given, theta is given. So the next thing is for us to calculate mu. We use the formula that mu is equal to tan theta. So let's get mu. That will give us tan 36 degrees, which will give us 0.73. So let's now put everything in our formula that P is equal to mu mg cos theta plus mg sin theta. So if we put all the values, we'll have here to be 0.73 times M times G times cos 36 plus M, which is 15 times 10 sine 36. So we are going to have the first as 88.59 plus, if we approximate everything, the force we are looking for will be 176.79 Newton. So what do you have to pick from this? Once you know that this force that will push it up the plane must overcome these two forces. It will be the resultant of these two forces. These two forces are acting in the same direction. So you add them up, substitute, knowing that this is F plus W sine theta. Then put your values and you will get the final answer. Let's look at another example. A concrete block of mass 25 kg is placed on a wooden plank inclined at an angle of 32 degrees to the horizontal. Calculate the force parallel to the inclined plane that will keep the block at rest if the coefficient of friction between the block and the plank is 0.45. Now we need the force parallel to the inclined plane that will keep it at rest. For it not to move, that means we have to find the difference between the forces acting on it. F is acting this way, then the parallel component of the force is acting this way. The frictional force is acting this way. Let's write out all the parameters that we have been given. Given the mass as 25 kg, given theta as 32 degrees, then mu is already given. Remember that the coefficient of static friction has no units, is given already. So let's get the force that will keep it at rest. The first thing we have to do is to find F. Therefore, F will be mu R, which is mu. Remember that R is mg cos theta. Let's substitute. We'll have 0.45 times 25 times 10 cos 32. That will give us the frictional force as 95.41 Newton. Then the next thing is for us to calculate this force. We have gotten this. Let's get this. W sine theta will be mg. Remember, W is mg sine theta. So let's substitute. We'll have W is mg sine theta. So m is 25 times 10 sine 32. So that will give us 132.48 Newton. So we have gotten this one and we have gotten this. Now the force that will keep the block at rest is the difference between these two forces. Then what we are looking for, that force will be 132.48 minus 95.41, so that the final answer will be 37.07 Newton. So this is the final answer.